finding area. Getting our brain started out here, 5/80 is equal to how much? 400. Remember, 5 times 8 is 40, and we had to add that 1 0 to make 400. 580 is equal to what? Once again, 5 times 8 is 40, and then add 1, 2, 3 more zeros onto 40. So 1, 2, 3 to get 40,000. 7 times 6, or 70 times 60, which is 7 times 6, is 42. And then we have to add 1, 2 zeros behind to get 4,200. 9 times 40, 9 times 4 is 36. We have to add our 0 of just 1 to get 360. 900 times 40, 9 times 4 is 36. And adding 1, 2, 3 zeros. 50 times 80, 5 times 8 is 40, and we have to add 1, 2 zeros to get 4,000. 7 times 60, 7 times 6 is 42, and we have to add our 1 0 to make 420. 700 times 60, 7 times 6 is 42. Add 1, 2, 3 zeros to get 42,000. 90 times 40, 9 times 4 is 36. And we add 1, 2 zeros to get 3,600 or 3,600. All right, your math journal today, we'll be taking a look at referencing things that are about how big. So if we were to think about 1 square inch, so that's 1 inch by 1 inch. That's going to be a very, very small area. 1 square foot is 1 foot by 1 foot. A lot of the tiles that we have on our floors are about that size. 1 square yard, a yard by a yard, that's maybe one of our bulletin boards that we have in a room at the front of the room. A square centimeter, a centimeter by a centimeter. Maybe you want to think about like the tip of your eraser. And 1 square meter, 1 meter by 1 meter. All right, you're going to be today developing ideas and strategies for finding areas of a non-rectangular figure. So like today, if we take a look at Math Journal page 309, we might need to be able to figure out what the size of this is based off of something else. So the directions say, however many times you need to find the area of a figure that is not a rectangle, unit squares will not fit neatly inside the figure. You won't be able to use the formula of an area of a rectangle. So how can we find the area of A, B, C? One way to do it is counting our squares and counting halves of squares and thirds of squares together. That is always one way to do it for our triangles. And remember that oftentimes if it is a perfect square or a rectangle, we can be using the area method, which is base times height. So in this case we'd be doing our base, which is 2, and our height of 2. 2 times 2 is 4. All right, in your SRB on page 190, it talks about the rectangle method of finding area. Many times you'll find the area of a polygon that is not a rectangle. Unit squares will not fit neatly inside the figure, and you won't be able to use the formula of the area of a rectangle. One approach that tells us that we can use is the rectangle method. Rectangles are used to surround the figure or the parts. Then only the areas that you must calculate for the rectangle and triangle halves of rectangles. Seems very complex, but if we were to take a look and to create, right here we see that we have a triangle. If we create a rectangle around it, then we can easily know that it's 1, 2, 3, 4, 5 units for the base and 1, 2 for the height. So 5 times 2 is 10. So this whole square area is 10, but the triangle only takes up half of its space. So 10 divided by 2 is 5. So that's 5 square units. Then if we take a look at a little bit more complex of a problem, let's say this one, we can maybe make 2 different rectangles. Okay. Here we have a 1, 2, 3 by 1, 2, 3, which is 3 times 3 is 9. Half, we're talking about just half of it. Half of 9 is 4 and a half. Then we're taking a look at this next section. And it's a 2 by 3, which is 6, and it's only half of it, so half of 6 is 3. So we could say that this figure is 7.5 square units. Taking a look at some more examples. If we were to take a look at number 1, we want to first make a rectangle. Okay, and now we have a full rectangle. Going to find the area of it. So it's 1, 2, 3, 4 by 1, 2, 3, 4. 4 by 4 is 16 square units, or we could count them all up. But we're only wanting to know this half of it. So half of 16 is 8. Taking a look at our next triangle, I want to make a rectangle to enclose it. Whoops. I have 1, 2, 3, 4 by 1, 2, 3, 4, 5. That's 20. I want to know half of it. Half of 20 is 10. And I need to enclose the second part of the triangle. So that is 2 by 1, 2, 3, 4, 5. So that's 10. Half of 10 is 5. Which is a total of 15. I would like you to go ahead and pause the video as you try to do number 3. All right, getting your answer for number 3, first thing we needed to do was to create rectangles. And this is how I would have split mine up. I have 3 separate rectangles. Right here there is no triangle, but I can easily count the blocks or know that it's a 2 by 1, 2, 3, 4, which tells us that this section is 8. Here we have a 4 by 3, which is 12, but I only want to know half of it, so this section is 6. We have a 3 by 4 again, which is 12, and half of that is 6. So 6 plus 6 is 12. 12 plus 8 is 20 square units. Once again, strategy is adding the parts. So first you're going to need to divide it into sections to have rectangles. And then you need to figure out what part is shaded. Is it half of it? Is it all of it that is in there? And figure it out. And as you watched, I would write what this little section would be equal to help me. You only need to be completing page 309 in your math journal using the rectangle method. Make sure that you're adding or creating rectangles to help you solve those types of problems. Once again, you're going to be creating rectangles. If I were to think about this one, I could break it up here and here, but you would see that this section is not included. So how else could you divide this one up to get into triangles? And you might have to look at it in a different way by turning it as well. You'll also be playing Frac-Tac-Toe today. Make sure that you are getting your Math Master with you. Taking a look at page 309 through 311 as well. That is the conclusion of today's lesson. Make sure that when you are using your rectangle method that you are dividing into smaller rectangles, looking for half which is a triangle. That will be a big success, or help you be successful today.